Hi everyone, welcome to our fourth episode. So in this episode we're going to look at how we read from our joystick, from our controller, so that we can actually work towards driving our robot. So in our last video we learned how to set the motors in Pros, and now in this video we're going to learn how to read from the joystick, and we'll see that it's rather much the same process. So we open up Pros, and here's the same code that we ended with last time. You'll see right here we have our same old motor set commands, and I want to talk a little bit about these. So with the motor set command, we had a name of the command, and then in parentheses we had two numbers, the motor port, and then the speed that we wanted to set the motor to. And we're going to see that it's much the same kind of format for how we read from the joystick. We're going to have a command with a name, and then in parentheses we'll have some numbers that are specific to what we want to do. And I want to talk about a couple things I didn't mention last time. So like you see, I created a bunch of blank lines here. That was just to keep the code organized and easy for us to read. These blank lines don't mean anything in terms of the code. Like whether if I deleted all these, the code would still work just the same and do the same thing. I just put them there so that it's easy for us to read the code. And same thing with these spaces here. I could delete these spaces and the code still works. Or I could put in random spaces somewhere here, and that would still work fine. It doesn't change anything. However, what does matter is the exact spelling and capitalization of the names of these commands. So motor set needs to be all lowercase except for the S in set, or else it won't work. And if I change this to be a lowercase s, you'll see that we get a red dot, which is telling us that there's an error here. And it's because this needs to be, it's case sensitive, it needs to be capitalized. Okay, so now for reading from our joystick, we're going to use a new command called joystick. And by the way, so I indented this just again to keep it organized. It doesn't have to be indented. I could put it all the way to the left like that and it would still work. But it's giving me an error because I didn't finish typing it. But to keep it organized, we indent it to the right. Like this, and we'll talk about more why we do that in the future. Okay, and so the full function that we want, let us go and take another look at the documentation so I can show you where this is coming from. Go back to their website. You can see in my history there that I've been looking for new camera solutions. I have a new solution that we're going to try today, and I have a third idea that I want to try in the next video that I think will be even better still. I think today's is better than the last one. Okay, so we're looking for joystick. Okay, and we see we have joystick get analog and get digital. And the get analog one gets the control axis, so the axis means the actual physical joysticks on the joystick. So this and this. And each joystick has two axes, the up-down axis and the left-right axis, and you can see they're labeled right here. The right one is 1 and 2, and then the left one is 3 and 4, with 2 and 3 being the up-down, and 1 and 4 are the left-right axes. So going back to the website, it gets the value from one of those axes. And joystick get digital gets the value of a button. So anything that's not one of those axes is a button. So all the buttons on the front here, these 8 buttons, and then of course also the buttons on the front of the joystick, all those are buttons, and you would use the joystick get digital for those. So let us start with the joystick axes. Let's start with analog. And so here, just like with our motor set command, you see that we had two numbers that we're going to put in the parentheses. The first is the joystick number. This refers to either using a primary joystick or a partner joystick. So if in case you've never seen this before, you can have a second joystick that's connected to your main joystick, so you can drive the robot with 2 controllers, so you can have 2 people doing it. And then the second number is the axis, so 1 through 4, like I was just talking about. And so this is kind of confusing because we have a controller called the joystick, and then on the joystick quote-unquote controller there are joysticks that have axes. So this is referring to the controller, either primary or secondary, the partner or main joystick. And then this is referring to the actual axis of the joystick thing on the controller, if that makes any sense. So yes, you can thank Vex for how they named their controller. I guess once V5 comes out, this thing will probably be completely obsolete, and maybe they'll have names that make slightly more sense. Okay, and so let's go back to our code. So we have joystick get analog, and so again, let me just point out that the capitalization here is very important. G and A are both capitalized, everything else is lowercase. And what you'll notice is that they capitalize the first letter of each word except for the first word. The first letter of the first word is lowercase, but the first letter of all other words gets capitalized. And that makes it easy to read and see like where words start and end, because there's no spaces in the names of these commands. Okay, and then our first number was the partner primary joystick. We're using the primary, so we'll use 1. And then the second number was the axis, and we want, let's use the up-down axis on the right joystick, so that means that we're going to put in the number 2. Okay, and you can look at your controller if you have one, and the axes are labeled so you know which one is which. But just to be clear, I put 2, so that means I'm using the up-down axis on the right, so like this. Okay. And now what this does here is it returns a value from -127 to +127, depending on where the joystick is. So depending on the position of the joystick. So that means that right now it's in the middle, so it would return 0. And when it's all the way down, -127, all the way up, 127. And if it's like just a little bit down, you get like -10, -20, -50, etc. A little bit up, it would be 10, 20, 30, 40, etc. until you get to 127 at the top. Okay? And so if we have this code now and we save it, we can build it, and then if we upload it to the robot, it won't do anything new. The robot will communicate with our controller. It'll find out where the position of the joystick is, but then it doesn't do anything with that. So it knows what this value is. The robot has it, but we're not doing anything with it. So we need to associate this now with some kind of output that we can actually observe as humans watching our robot. So one way that we can do that is by using our motor set command from before. So let me just delete these spaces that I made for no reason, because it's bugging me. So we learned before that this was the motor port, and then the second number, oh crap, sorry. The first number was the motor port, and then the second number was the speed that we want to set the motor to. And we found out that that speed can be a number from -127 to +127, depending on how fast and in what direction we want the motor to turn. And so, rather conveniently, we learned that joystick analog also returns value from -127 to +127. And so, that aligns very nicely with our motor set numbers. And so what we can actually do here is take this and put it right inside motor set. And so now we set the motor on port 3. Sorry, we need to delete that semicolon. We set the motor on port 3 to the value of our joystick axis. So this command here, joystick analog, literally becomes the number in the code. It becomes the number associated with the position of the joystick. And so by putting it in here, we are setting the motor to whatever number it gets from the joystick. So when it reads the joystick, it finds out the position, and then that's a number here, and then we set the motor to that number. And you'll see that works very nicely. So let us build this. We need to save it. Okay, it built successfully, and then we're going to upload it to the robot. Nice. Okay, and now let's switch to our camera. Okay, and now I need to connect the controller to the robot. Okay, and apparently my controller is dying. But so I said I used number 2, which was the up-down joystick on the right. And as you can see, oops, you can't see because I'm blocking it. Now you can see, when I move this joystick, the wheel turns, and it turns faster if I pull it further, and it changes direction if I move it in the other direction. Okay, so now we've learned how to control a motor using our joystick axes. Okay, and so perhaps maybe instead of using the right axis, maybe we want to use the one on the left. So if I wanted to use up down on the left, I just look at the number on my controller, and it's 3 is the up down axis on the left, so we change that to 3, build it, and then I need to plug the robot back in with my USB cable. And upload it. I pressed upload too quickly. It hadn't connected yet. Okay, now uploaded. And then we switch back to the VexNet key. And let it connect. And now the same wheel should move when I move the left axis on the joystick. So now I'm using the left one, and look at that, the wheel moves same as before. Okay, and if I replace the number, instead of 3 I used 4, say, or maybe I used 1, then I could use the left-right axes. And my controller's dead now. Okay, so there's how we can use joystickGet analog to control motors using the joystick axes. So now, if you remember, there was a second command called joystickGet digital, and this was for all the buttons on the joystick. So let's take a look at how we could also use that to control motors. So this one is going to have 3 numbers in parentheses instead of just 2. The first number, just like before, is either the primary or the secondary joystick, so 1 or 2. And then the next is the button group, and that refers to the groups of buttons. So right here you have group 7, group 7 is on the left, group 8 is on the right, and then the front buttons are 5 and 6. And if you're looking at this in real life, you can read your own controller, I'm sure, just fine. I know mine is hard to see in this video. Okay, so we have the button group, and then we have the specific button within that group, which can be up, down, left, or right, and I think those are pretty self-explanatory. Groups 5 and 6 were the buttons on the front of the joystick, and so there's no left or right on the front, there's just up and down. So I think that's pretty self-explanatory. Okay, so let's go back to our code, and we'll just start by writing that command, joystickGet digital, and then in parentheses. Also, you notice that when we type the name of a command correctly and we put the parentheses after it like it should, it turns blue. Okay, so that's just another way that Atom helps us keep our code organized and easy to read. And that'll be all this kind of stuff I'm talking about for organization will be super helpful when we start writing really long codes. Okay, and so the first number was primary joystick, and then the button group. So let's use the buttons on the top right, so that is group 8, and then let's say we want to get the right button, so joy underscore right. Okay, and you see here that using joy right is different than what we're used to, because we're used to just putting numbers here. But here in our documentation, it tells us that we have the option to use these special terms, I guess we'll say. So joy up, down, left, and right. And they need to be spelled exactly like we have here. So all caps and separated by an underscore. And what we'll learn later is that these terms are actually numbers, but they've written code to represent them using these letters. But for right now, it doesn't really matter how it works. We just need to know that you use one of these special terms here for the third element that we put in the parentheses. Okay, and then as always, we end our lines here. We end each command with a semicolon. Okay, so now this will return the value associated with the right button in the 8th group on our primary joystick. And so with the axes, it returned a number between -127 and +127, but this is a little bit different. So it returns true if it's pressed or false otherwise. Okay, so this is quite a bit different. So what do we do with true or false? Well, true in this case is a 1 and false is a 0. So just as this became a number between -127 and +127, this will become either the number 1 or it will become the number 0, depending on whether the button is pressed or not. So if we were to just put this here in our second motor's speed spot, then we would be setting the motor. Again, we need to delete the semicolon. So you just have one semicolon at the end of the entire line. You don't have one in the middle there. That would be bad. This will return. We'll be setting the motor to either a speed of 0, which would be off, or a speed of 1, which would be way too slow to observe. So if I just upload this as it is right now, and let me plug our robot in. Upload. Okay, and then since my joystick died, let me use the USB cable. Okay, and so now when I press the right button, nothing happens because the number 1 is too low of a speed for us to observe anything. So we need to somehow make the number bigger than 1 when the button's pressed. But 0 for when it's off is still okay. Sorry, I just need to plug this back into the computer now. And it's upside down. Classic USB troubles, right? Okay, so how can we do that? How can we make this number bigger? So what would be something better? So maybe it would be better if it was 127 when the button's pressed, right? Because then that would be the fastest we can go forwards. And if it were 0 when it's not pressed. So we have 0 and 1, and we want it to become 0 and 127. So how can we do that? So what if we say it's going to be 127 times joystickGet digital. So now, if joystickGet digital is 0, 127 times 0 is still 0. And if it's 1, 127 times 1 is 127. So let us try how this works. Oh, and also I want to change this motor to be port 7. Actually 8, I believe. We're using different motors today. It'd be really great like if I had a robot just for the purpose of making these tutorials, but I don't. So we're just using the robot that I do have. Okay, so now download, let's go back to this, and we grab our USB cable. Plug that in, wait for it to connect, and so now motor 8, if I was right, should be the motor on the left there, and I was slightly off, it's actually the back motor. So you can't see it, but the back motor is turning now. So let me just fix this here. So motor 127, I think. So I'm just going to upload the code one more time. Maybe like by the next video I'll actually remember which motors are in which ports. Probably not. Maybe I'll be smart and write it down, and then I can like cleverly reference it without having to make these mistakes. Okay, so I fixed that. Watch it, it's still a third port. There we go. So now you see when we press the button, the wheel spins, and when we let it off, it does not. It stops. So we send it 127, and we send it 0. And we still have our other function, our other command, where we set this wheel to the joystick value. I thought the left joystick. That's right. So now we have two wheels controlled by two different buttons on our joystick, the axis and the button. And so I want to talk about this a tiny bit more. In our code, what you see we did is that we did some math here. So we multiplied 127 by our joystick button value. And so we can totally do that. We also could, for example, do like 127 plus that, although that wouldn't accomplish what we want. We can do subtraction, we can do division, and then star is multiplication. Okay, and so that's going to be useful all the time in the future, just to know that we can do this kind of math operations on stuff. Alright, so that's how we can control motors using our controller. And now in the next video, we'll learn how to actually write our first driver control routine and start driving this robot.